Hello, esteemed viewers. In this tutorial, we describe two-dimensional arrays in C. And some of the important points about these two-dimensional arrays are, they are also called as matrices in mathematics. Matrices is to mathematics, two-dimensional arrays is to programming. Every element in a two-dimensional array is to be accessed in two references, one along the row and the other along the column. Let us give a practical example. The practical example being, we have a list of student names along the rows and the marks scored by the students in 5 different subjects. And if you have 20 students, this matrix will be 20 into 5 number of subjects and 20 students. And in order to find the student marks in a particular subject, we need to go along the row where student is against the student name, and we have to hit the subject along the column, and the intersection of this row and column will elicit the marks obtained by the student in that particular subject. Therefore, every element in a matrix or two-dimensional array is to be accessed in two directions, one along the row and the other along the column. And each element is double subscripted. Therefore, if A is the name of the matrix, or if A is the name of the two-dimensional array, it will come with two subscripts, that is I and J. That means we are referring to an element of that is present in ith row and jth column. One for the row. The first one is typically for the row, and the second subscript is for the column. It has a matrix or a two-dimensional array has lot of applications in engineering, data analytics, image processing and signal processing. For example, an image of having a frame of, let us say, 512 by 512 pixels is nothing but a matrix of intensities. The number of intensities being represented in the matrix form, and the total number of intensities will be equal to 512 into 512. That means there will be 512 rows and 512 columns. And the process will start with declaration of two-dimensional array. Anyway, any program involving two-dimensional array should find declaration in the beginning itself, like we did for one-dimensional array. Here there are two examples: integer a, 3, 2. That means A is an integer array or integer matrix consisting of integer element placed along 3 rows and 2 columns. Anyway, the matrix A or two-dimensional array A will have 6 elements. Similarly, in the same token, X is a matrix which contains float kind of elements, 9 in number, because they are organized in 3 rows and 3 columns. We can also initialize two-dimensional arrays like we did for one-dimensional array in our previous discussions. Integer array A, 4 and 3, it consists of 4 rows and 3 columns. This is the first row consisting of 3 elements along 3 columns. This is the second row, and this is the third row, and this is the fourth row. And you should notice in every row is delimited by semicolon, and also the entire matrix is placed in a block, and it is also delimited by semicolon. And we can read the matrix, elements of a matrix through the keyboard, something like this: I equal to 0, I less than 3, I plus plus. This will create 0, 1 and 2 because it is less than row. Therefore, this will create 3 rows, and this will create 2 columns. The outer for loop is to create rows, and the inner for loop will be able to create the columns. In the first cycle, it goes like this: it is 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1, because this is less than 2, 0, 2, 1 will be the third row. 1, 0 and 1, 1 will be the second row. 0, 0 and 0, 1 will be the first row. And whenever we need to enter whenever when the program is in execution is something like this. Okay, it is 3 rows and 2 columns. Okay, first element is to be entered and we should leave a space, then we should enter the second element, then we will hit the enter key, then we will go for the second row, and this is the first element in the second row, and space the second element, and we have to hit the enter key. Then once again the third row, the 5 is the element, space, and 5 is the another element, then we should hit the enter key. And this is the way in which we will enter the input, just like a matrix. And while we write a matrix, it cannot write automatically in the matrix form. We need to program for this. For I equal to 0, I less than 3, I plus plus. Okay, anyway, every row should have a gap. Therefore, this is the block, this is the for loop. Okay, under this outer for loop, there are 1 and 2 statements, and this printf is under the control of the inner for loop. Therefore, we need flower braces, because the outer for loop block which will create rows has 2 statements. One is the for loop, for statement, the other one is printf/n. This will create, so this will print every row. It is something like this: 0 0 0 1 1 0 1 1 2 0 2 1. Something like this, and it will be printed. As soon as 0 1 0 0 and 0 1 is printed, there is a percentage, there is a /n. It will create a line. Therefore, there will be a spacing between the lines. Okay, rows will be independently printed, and it will just look like a matrix. Out. We will go through examples in order to reinforce our understanding on these matrices or 2-dimensional arrays. We can use matrices or 2-dimensional arrays interchangeably, therefore there is no problem. This program adds 2 matrices of size m into n and p into q. Okay, actually we have taken only m into n. Anyway, I will just delete this. Okay, size m into n. Okay, I will tell, let us understand as to what we should do if 2 matrices of different sizes are given. Okay, we are adding the 2 matrices. We will assume that both the matrices are of size m into n. This is the compatibility condition. In order to add 2 matrices, the number of rows should be equal to number of columns in both the matrices. Okay, so we have included stdioh conio.h, and there are 2 matrices that are declared: A 20 20, B 20 20, and A and B will get added and generate C. C is the resultant matrix. So I and J is meant as loop indices. So also K and L, N and M, it is the size of the matrices. Enter the order of 2 matrices. Okay, it is M and N. Enter the elements of A and B row wise. Okay, this will input the elements of matrix A. So I equal to 0, I less than m, that is m rows, j equal to 0, j less than n columns. Enter A %d ij. So here what happens when we start executing, whenever we start executing, this prompt will appear cyclically. Enter 0 0, enter 0 1, 0 2, 0 3. First row is over. Let us say 1 1 0 1 1 1 2 1 3, like this. So the program will be little interactive, and the user will be guided to enter the values of the elements. Okay, this will take a matrix A of size m into n. Similarly, this will take the matrix B of size m into n in the same interactive way, and addition takes place here. I equal to 0, I less than m, I plus plus. For j equal to 0, j less than n, j plus plus. Okay, this will add along the rows. So the first element of the first row and the first element of the second row will be taken of A. First element of the first row of A, first element of the first row of B will be added, and you know all these things anyway. For the sake of practice, we are doing this, and my respected viewers can definitely try the subtraction of the arrays in the similar way. print of the resultant matrix is, okay, here we have generated C array, C matrix by adding A and B, and we will just print this over here. I equal to 0, I less than m, I plus plus, j equal to 0, j less than n, j plus plus, m rows and n columns, percentage 3d, we have a space of 3, and we can increase this depending upon the nature of the values of the elements. If the elements are 3 digited, then it is preferably we can make it 10d, percentage 10d, so that between the elements there will be space, and that itself will get formatted, and we will get the matrix in a very neat format. Okay, so output, one time run is being done and it is being captured. Enter the order of two matrices, 2 into 3, that is 2 rows and 3 columns. Okay, enter 0 0. See, this is the nature of guidance. Okay, this is how we can make the program interactive. Enter a of 0 0, a of 0 1, and we are just entering. So this will form the first row 1 2 3, the second row 4 5 6 of the first A array, A matrix, and this is 1 2 3 and 4 5 6. When we add, 1 plus 1 should get added, we should get 2, 2 plus 2 will be 4, 3 plus 3 will be 6. So we have got the resultant matrix over here upon addition. We will go for the second example. In this program finds sum of the elements along the rows and some of the elements along the columns of a given matrix. Therefore, since there will be number of rows and there will be a number of columns in a given matrix, we need to generate the sums independently, and we will put the sums along in a one-dimensional matrix. As many rows as is the size of the arrays and array, okay, row array, and as many columns as is the size of the column array. Okay, they will collect the sum along the rows and sum along the columns. So here it is integer a 10 10. So this contains maximum of 100 elements, 10 rows and 10 columns. Row sum, this is the array which will collect the sum of all the rows, sum of the rows independently rather, and this is column sum of the columns independently, j, I, these are all the loop indices, m and n is the size of the matrix. So enter the size of the matrix, m and n, enter the elements row wise, that is m rows and n columns, and we have entered the elements of an array. Now the matrix is, and we are printing the matrix because we should get the clue as to whether the sum is happening along the rows correctly and sums are happening along the columns correctly. So the sum is done now. This is row sum. Okay, for I equal to 0, since there are m rows, we have to have the outer for loop to be 0 to m, that is 0, I equal to 0, I less than m, I plus plus, because there are m rows and every row is different. Therefore this will act like an accumulator. Row sum I, that is row sum 0, this is the first element of row sum, okay, which brings in the sum of the elements along the row 0. So row sum equal to 0. Now we will go along the columns, j equal to 0, j less than n, j plus plus. Row sum I, that is row sum of 0, equal to row sum I, row sum 0 plus a of ij. A of ij means 0 1 0 1 0 0 0 0 1 0 2 0 3. So we are going along the rows simultaneously accruing value of each and every row in a variable called as row sum, and row sum is exactly array containing number of elements which are equal to the number of elements are equal to the number of rows present in the matrix. Similarly, as far as we are printing this, you can clearly observe over here, for I equal to 0, I less than m, I plus plus, so as many rows as is the size of this array. Okay, sum of the row number percentage d equal to percentage d, I, that is 0th row, first row, second row, like that it will be printed over here, and accordingly sum will also be printed. Now column sum is done. Now since we are taking the sum of the columns, the outer for loop should be equal to number of columns. So j equal to 0, j less than n, j plus plus. So outer for loop will generate columns. So column sum of j equal to 0. Now for I equal to 0, I less than m, I plus plus. So column sum j equal to column sum j plus a of I comma j. You can look over here. Okay, j is 0, I will go from 0 to m. Therefore it is it is 0 0 0 0 1 0 2 0 3 0 4 0. So we are going along a column. We are going along a column. So now we will print the sums. For j equal to 0, j less than n, because n number of columns are there, we are independently printing them because all the sums of the columns are available in column sum array. So now we will take an example. Enter the size of the matrix, 3 rows and 2 columns. Enter the elements row wise, 10, 11, 12, 13, 14, 15. So we are entering just like a matrix. Okay, 10 space 11, enter. 12 space 13, enter. 14 space 15, enter. Okay, the matrix is, this is out of formatted printing. Okay, using two arrays. One outer for loop will generate rows and inner for loop will generate the columns, and there is a slash n, printf slash n, which will create the space between the rows. So sum of the row number 0 is 10 plus 11, 21. Sum of the row number 1 is 12 plus 11, 25. Okay, 12 plus 11, it should be 23. Okay, 14 plus 15, it is 29. Okay, it is 29. Anyway, sum of the column 0, 10 plus, there is a mistake over here, 10 plus 12 plus 14, 36. Okay, and sum of the columns number 1 is 39. We will change this. 12 plus 11, 23 it is. Okay, now this program finds transpose of a matrix. As we know, transpose means making columns of a matrix into rows and rows into columns. And we don't want to lose the original data, therefore we will create a separate matrix which is transpose matrix of the original matrix, which is transpose of the original matrix. So we have declared A 10 10, B 10 10. Okay, they should be same, temporary variable, because we don't want to lose the data. Okay, we will do it by swapping, of course, I, j, m and n. Okay, this is for size of the array, and I and j for the for loop. Enter the size of the matrix m and n. Enter the elements of the matrix row wise. So I equal to 0, I less than m, I plus plus, j equal to 0, j less than n, j plus plus, and we are reading this particular array. Okay, the matrix is, we are printing in order to get a clue as to whether our transposed matrix comes in the correct way. Okay, we are printing the original matrix over here. I equal to 0, I less than m, I plus plus, j equal to 0, j less than n, j plus plus, percentage 6d in order to leave a sufficient gap. Okay, a of ij and slash n. And here transposition is happening. For I equal to 0, I less than n, I plus plus, j equal to 0, j less than m, j plus plus. Now there are n rows and m columns, and in the original matrix there are m rows and n columns. Accordingly, b of ij will be equal to a of ji. Okay, a of ji. b of ij means, okay, 0 0 0 1 0 2 0 3 will be equal to, as far as a is concerned, a 0 0 0 1 0 2 0. So these are all columnar elements. So columnar elements will go and sit in the row of B, okay, and vice versa. Transposed matrices, we will just print this. Okay, there will be n number of rows and m number of columns. Okay, 6d in order to leave a gap, as I told you earlier, b of I comma j. Now this is actually run on box code. Okay, enter the size of the matrix A 4 by 4. Enter the elements of the matrix row wise, 1 2 3 4 5 6 7 8 9 10 11 12. See here, since the inputting of the elements are not formatted, we just enter in a normal way. We enter 9, leave a space and enter 10, leave a space, enter 11 and leave a space, enter 12, and we will hit the enter key to enter the fourth row elements. And when we print it, it will come in a neat formatted way because we have used percentage 6d. So it is printed in a very neat fashion. Now the rows of this matrix will become column. See here, 1 2 3 4 1 2 3 4 5 6 7 8 5 6 7 8, like this. The rows have become columns and columns will be columns of the original matrix will become rows. So in this tutorial we did some primitive computations using matrices or on matrices, and we will come up with little complicated programs using matrices or on matrices in our next tutorial. Until then,